Hello, so we'll try to look into these review questions from Algebra 2. Let's look at the first question together. First, we're looking for sum of these two irrational numbers, or actually imaginary numbers. Notice that we have negative numbers, negative signs inside of the radical. Soon as you see the negative sign, we can imagine that this one will be an imaginary number. In a way that this will be equal to I square root of 25. Of course, it is quite easy for us to simplify radical 25, but notice that we have I. This I, once again, comes from the negative, having a negative sign right in the inside of the radical. If you have to simplify this one further, then since square root of 25 is 5, we will end up getting 5I. Now, and this one therefore becomes, first you can write it as 2I and square root of 9, but square root of 9 is equal to 3. So 3 times 2 becomes 6I. And then when you add them up, because they're asking for the sum, our final answer becomes 11I. Alright, let's look at the next question. Similarly, here, as soon as you see the negative numbers inside of the radical, we can assume that to be an imaginary. So here we have I square root of 48. And then here we have I square root of 27. Now, of course, if you think about square root of 48, two numbers that multiplied 48, and then we are looking for some sort of perfect square. Yes, one way which we can do this will be equal to I square root of 16 and square root of 3. Square root of 16 becomes 4, so here we have 4I radical 3. On the other hand, here, square root of 27 becomes I square root of 9 and square root of 3. Then we end up getting 3I from radical 9 and then radical 3. So radical 27 will become this number. So if I have to rewrite everything, what we end up getting is this. Instead of writing square root of negative 48, we will have 4I radical 3, and then plus 3.5, and then square root of 25 becomes 5 itself. And then the last number becomes 3I radical 3. And here, we can combine two like terms, such as these two. Hence, we end up getting 7I radical 3, and then the first one becomes 8.5. Now, this is a correct answer, but some cases, since the question is written in a plus bi format, where I is all the way at the end, what we also can write this one as 8.5 plus 7 radical 3, and then having the I all the way at the end. Alright, that was number 2. Let's move on. Okay, here we have, we just have to multiply these two numbers. So 3 multiplied to 1, we end up getting 3. And 3 multiplied to negative 3I becomes negative 9I. Then we have 2I times 1 becomes plus 2I. And then 2I times negative 3I. So therefore we get negative 6I squared. Now, here we can combine these two terms, which will end up getting negative 7I. And then we already have 3. But here I squared becomes negative 1. But we already have a negative sign in the front, so negative becomes positive 6. So when you combine 3 and 6, we will end up getting 9 plus, 9 minus 7I. That's what we end up getting. Now, number 4 is actually a very important question. You see, if you have to write up, in order for you to calculate questions like these, we need to know the sequence of i's. So for example, I to the 0 power, yes, it is equal to 1. I to the first power, yes, anything to the first power will be itself, simply I. I squared by definition will be equal to -1. And I to the third, in fact, if you think about I to the third, you can combine these two things together. So therefore, what we end up getting is -I. And I to the fourth, yes, I to the fourth, in fact, is equal to I squared times I squared. But each I squared is equal to -1, so this will be equal to -1 times -1, which will simply become 1. But you will notice that 1 has repeated from the original. And then I to the fifth power will go back to this one. So in fact, what's very, very important for us to do is memorize the sequence. Either exponent is 0 or multiples of 4, it will always become 1. And then when the remainder is 1, then I squared becomes -1, and then cube becomes -I. So if you have to rewrite this one, I to the 8th power, since 8 is multiples of 4, we will end up getting same value, which is equal to 1. Now, 9, in fact, when you divide by 4, because 4 of them makes up one cycle, the remainder will be equal to 1. Because closest multiples of 4 will be 8. So here, this one will be equal to plus I. Second one becomes, when you divide 10 by 4, which is the cycle, then you will get 2 as a remainder, so we will have I squared. And here the last one, when you divide 11, the exponent, by 4, you'll get 3 as a remainder, so we'll end up getting this one, plus I cubed. Now, then this becomes, first one becomes 1, second one becomes I, third one becomes -1, and fourth one becomes -I. So therefore, everything cancels out to become equal to 0. So choice number 4 will be our answer. All right, let us move on. Number 5. Here, so if you see, if you divide 99, which is the exponent of the first one, by 4, then you will realize that 2, which we get just 8. So we end up having 19 through the long division. And you could have 3, which is, you could have 4, which is equal to 16, and the remainder is 3. You see, this is the remainder. Meaning remainder is 3, that means I to the 99th power is in fact equal to I to the third power minus given I to the third power. Since we are subtracting the same value, we will have gotten number 4, 0. Here we have product of I to the third power times I to the 7th power. Then in this case, this becomes I to the 10th power. But when you divide 10 by 4, the remainder will be equal to 2. So this becomes I squared. But what is I squared always equal to? To -1. Therefore, choice number 2. All right, so let's look at the next value here. See, this exponent 3 will apply to 5 and also I 2. Now then, what does that become? So 5 to the third power, but I to the 9th power. Because between two exponents, you got to multiply them. So what we end up getting is 5 to the third power becomes 125. How about I to the 9th power? I to the 9th power, you have to divide 9 by 4, then you will get a remainder of 1, which is equal to I itself, so 125I, which will be choice number 2. Now, here number 8, we are given a function f of x equals x squared, and then here we have I to the third power in place of x. Then f of I to the third, it's got to be equal to I to the third square by using this expression. Then here we end up getting I to the 6th power. But when you think about it, I to the 6, when you divide 6 by 4, this will be equal to I squared, which is equal to negative 1. Choice number 2. All right, here what we're going to do. First, let's convert the numerator into imaginary number. Then this becomes I square root of 50 over square root of 2. But you will realize the square root of 50 is in fact equal to I square root of 25 times square root of 2 divided by square root of 2. Then you will realize that square root of 2 is cancelled out. This simply becomes 5i, which is choice number 3. Now here we have to simplify. Alright, then if you have to rewrite this one, we will have 12 plus 3i. We don't have any problems with that so far. But this negative sign has to be distributed in a way that 3 minus I becomes negative 3 plus I. And obviously we can combine these two terms and then those two. So we end up getting 9 because 12 minus 3. And 3i plus I becomes 4, so we're going to have 9 plus 4i. Alright, so there it goes. Number 11. Subtract this one from here. That means what we're actually looking for is a negative 2 plus 3i and subtract 3 minus 2i. Then what do we end up getting, guys? Negative 2 plus 3i minus 3 plus 2i. Now, then what do we end up getting, guys? So we have negative 2, and then negative 3 becomes negative 5. And then 3 and 2 becomes plus 5i. That is the answer for this question, number 11. Number 12. What is the additive inverse? Additive inverse simply means switching the sign so that you will end up getting additive element, which is equal to 0. So what we end up getting is this. A plus bi. What should we add on to this one so that we can get 0? In order for you to get rid of a, we should have had negative a. And how about bi? Would have been negative bi. So we end up getting choice number 4. Alright, let us move on to the next question. Number 13. Here once again, you have to divide 25 by 4. And we end up getting 6, which is 24, with the remainder of 1. So that means this one is equal to I itself, which is choice number 3. Now, I to the 55th power, here we're going to try to do the same thing, 55. And then 4, we end up getting 4, which is equal to 15. And 15, you get to realize that we can try to put 3 here, then we end up getting 12 over 3. So 3 becomes our remainder. So that means this is equal to I to the 3rd power. Now, so what is I to the 3rd power? If you remember clear, they will be equal to negative I. Negative I, choice number 4. Alright, here we have which number is not including. So let's try to plot each one. Negative 0.5i. I is up and down. Negative 0.5. It's got to be 1, 2, 3, 4. So we are looking at around here. Now negative 5, which would have been around here. And then negative 1, which will be still inside. Negative 9 will be simply very close to that. But negative 9 and then negative 9i. In fact, this becomes not part of it. Now number 16. Z1 and Z2 are given in this way. What is Z2 minus Z1? Z2 is 4 minus 3i. And then the other one will be minus Z1. Z1 is negative 3 plus 2i. Now here we have 4 minus 3i, and then plus 3 minus plus 3 and then minus 2i. So if you combine them together, we will end up getting 7 minus 5i. Where is 7 minus 5i? 7 in x direction here, and 5 in, or negative 5 for that matter, has to be another value. That means we are looking at value around here, which is in the fourth quadrant. Right, so let's look at the next one. So here we have negative. So as soon as we see the negative, then we can take out negative and it becomes radical 300. Now, as we all know, this one is equal to I and then square root of 3 times square root of 100. And square root of 100 is equal to 10, so we end up getting 10I radical 3. That becomes our answer. Choice number 3. Now, question number 18. Here we have sum of these two. So once again, here it becomes I square root of 2. Here we have I square root of 18. Now, then what is 18? 18, in fact, can be broken down into square root of 9 and square root of 3. So therefore, what this one becomes is equal to, here 9 becomes 3, so we have 3I. Oops, this becomes 2. Radical 2. So 3i radical 2 and then I radical 2. So when you combine them together, it becomes 4i radical 2. Alright, so let's look at number 19 here. Expressed in simplest form. Now once again, we're going to simplify each one here. First one is 2i square root of 50. That's how we can simplify it first. Now this one becomes then 2i, 50 becomes square root of 25 times square root of 2. That's how we can separate this one. And this becomes, here square root of 25 becomes 5. 5 times 2 becomes 10i square root of 2. On the other hand, here we have negative 3 square root of negative 8. Now, as soon as you realize this one, this becomes negative 3i square root of 8. Now, square root of 8 becomes negative 3i. Radical 4 becomes times radical 2, which ends up being negative 6i radical 2, because radical 4 and then 3 multiplied together become radical 6. So once we subtract this one minus this one, we'll end up getting 4i square root of 2. That's our answer, which is choice number 3. Now, next question is we want to subtract this one from here. That means 3 radical negative 18 minus 2 radical negative 2. That is the question ultimately. So here, what is square root of negative square root of 18? Square root of negative 18, in this case, we end up getting 3i first, and square root of 18. And here we have minus 2i square root of 2. Now, once you break this one down, we'll end up getting 3i. Here we have square root of 9 times square root of 2. That's equal to square root of 18. Now, and the second portion is simply 2i radical 2. And then once you simplify this one, this becomes a 3. And this one already have radical 9, which becomes 3. So we have 9i radical 2 minus 2i radical 2. And here what do we have? 7i radical 2. That becomes our final answer, which is choice number 1. Alright, let's move on to the next question. So here we have two complex number, one right here and one right here. But they want us to graphically represent the sum of those two. How are we going to get it? First, Uh, 3 plus 4i, that means from here, 3 is the x direction, real number, and then 4i. We have to go 1, 2, 3, 4. That would be 4i. And 3, so we end up getting this point. So if I had to sketch it, it would have been something like this. Now, using blue, I'm going to mark the second one, -1, and then +2. If they want us to combine those two things together by addition, then what are we going to do? In fact, another way which we can do it is, if I transpose this vector all the way up here, then you will realize that wherever it ends, which is right over here, that becomes our final answer. See? Now, then that becomes +2, and then plus 6i. Alright, that becomes our answer. Let us go for number 22, the root of this. Now, whenever we are looking at roots here, what we have to remember is the discriminant. Discriminant, let me just call it out as a big D, is equal to square root of b squared minus 4ac. Now, the inside portion, that's basically what we're looking for, because you see when you this square root actually comes from the quadratic formula. And then whatever's underneath of that becomes the discriminant. Now let's try to figure out the first one here. B is the -5, so -5 squared minus 4 times A becomes 1. C becomes also 1, 2. Then here we end up getting 25 minus 4, which is positive. Which we end up getting 21. What is 21? 21 is positive, so therefore we're going to get the real. And then, since this is not a perfect square, we will not be able to get the rational roots. We'll end up getting irrational roots right here. Similarly, here we have b in this case will be -8 minus 4 times a, which is 2, times c, which is -4. That's what we end up getting. This becomes 64, and then plus, because negative become positive, plus 32, which we now get to be 96. Now, since this is not a perfect square, but it's positive, so we'll end up getting the real number right over here. All right, now, next question, number 24. Juan has been told to write a quadratic equation whose sum of the roots is equal to -3. You see, sum of the roots is equal to negative b over a, and that happened to be equal to -3. I'm going to leave some space here, and then product of the roots, in fact we know that this is c over a from the quadratic equations, has to be equal to now -9. Now, then in this case, one thing that which we can do is this. You will realize, assuming a is equal to 1, what we end up getting is negative b is equal to -3. So therefore, b must be equal to 3. Then we have x squared, and since b is equal to 3 plus 3x, now let's look at the last one. Since if a, assuming that a is equal to 1, then we end up getting c is equal to -9, and then minus 9 is equal to 0. That's what we end up getting. Now, and then in this case, we don't see anything particular. This one is very close to our answer, but it doesn't quite meet it because we have negative 9 here, but positive 9. In fact, our answer would have been this one without negative 180, but this would have been negative 18, because in this case, if you factor out 2, what we end up getting is x squared plus 3x minus 9, which is equal to what we have. So therefore, choice 3 would have been our answer, assuming that there's no 0 at the end, right here. Let's move on to the next question. Now, 12 is a 1 root. What does that mean? 12 is 1 root. We could do this one in a couple of different ways. You see, the product of the root is negative 36. This must be the other root r1 times 12. And we end up getting 12r is equal to negative 36. Then by dividing it by 12, r must be equal to the negative 3. Now then, k, in fact, by the sum of the roots, sum is equal to negative b, which is equal to negative k, over x, coefficient of x squared, which is equal to 1. So k is equal to sum. Then what do we end up getting? Negative 3 plus 12 must be k. Then here what we end up getting is k is in fact equal to positive 9. So our final answer becomes positive 9, choice number 1. Now let us look into the next question. If the sum of the roots here is added to the product of each root, so then what is the sum? Sum is equal to negative b, which is simply negative 3 over a. A is equal to 1. Therefore, this becomes negative 3. What is the product of the roots? Product becomes simply c over a, which is negative 5 over 1, which is equal to negative 5. But when you add up those two things, we'll end up getting negative 8. Choice number 4. All right, let us look at a couple more questions. Number 27. Jacob is solving a quadratic equation. He executes a program on his graphing calculator and sees that the roots are real, rational, and unequal. This information indicates that Jacob is discriminant as well. The fact that we have rational, that means it should be perfect square. Now then, which is choice number C. Now number 8, the roots of, so here we have to look at the discriminant first. What's the discriminant? Is equal to b squared minus 4ac. Now b here becomes negative 2, so we're going to have negative 2 squared. A now becomes 5, so negative 4 times 5. And the c value is equal to 1. So here we have 4 minus 20, which is equal to negative 16. Now the fact that we have negative 16, then what does that mean about the roots? Roots are imaginary, which is choice number B. Now number 29. Once again, this one has to be imaginary. What does that mean? That means the discriminant has to be less than 0. So we have 6 squared minus 4a, c becomes negative 9. And this one has to equal to 0. So we have 36 plus 36a. Therefore, a must be equal to -1. Now, in fact, this one would have been equal to 0, so, but actually, we are looking for this one to be imaginary, so therefore, I'm sorry about that. Well, we have to use the different inequality sign, which is this one has to be less than 0, so therefore here we have a has to be less than -1. So a has to be less than -1, then we are looking for choice number D. Alright, that's it. Have a nice day. I'll see you later.